Dear learners, myself Professor M.D. Agrawal, in this session, 5th session of second week of our course Managing Industry 4.0, today we are going to discuss very important technology, computer vision and visual AI, which are part of, I consider the part of Industry 4.0 foundation technologies now. The agenda of today's next 25-30 minute session is we will try to revisit augmented technologies, how they are helping the mankind, knowledge workers, factory workers, and then we will have technical discussion and some industry use cases on computer vision and virtual AI. And then we will end this session with summary of this week's learnings now. So let us now move. As you are seeing in this picture, artificial intelligence is an umbrella technology, and it has given the birth of many technologies like such as machine learning, natural language processing, NLP, deep learning. And now today we are going to discuss computer vision, that is sometimes we call as extended version of computer vision as a visual AI, which I will be going to explain you. If you see that artificial intelligence tree structure, the visual AI or computer vision is based on the foundations of artificial intelligence, or if I like to say that foundation of computer vision and visual AI, which we are going to discuss today, is artificial intelligence. The next slide is you are seeing, which we have discussed earlier also, that some of these technologies like augmented reality, virtual reality, computer vision, robotics, and now today visual AI, they are considered as a augmented technologies. They have a major role in augmenting the capability of knowledge workers, factory workers, and in general humankind. And in the same domain, computer vision is also one of the important technology which we are going to discuss. I like to now play a video, and this is a video from BMW, how BMW is using artificial intelligence and visual AI for detecting the faults and many other things. You yourself see this, the importance of this technology through this video. So you have seen the technology in action, AI technology in action, detecting the faults, verifying what workers are doing is correct or wrong. If there any defect in the spare parts, that is being visualized by the camera and then being diagnosed by the software. So this is I thought we'll start our today's session with a live example, and BMW is a world's one of the high quality four-wheelers, and we know about that, high value and high quality four-wheeler. We have seen that the use of the AI technology and in particular computer vision and visual AI in automobile is very, very large. Now with this context, if you like to revisit the functional part of artificial intelligence, I like to define in three categories. One is that what is the role of AI as an assistance, as an assistance where AI is assisting the humans. As we have seen in that video, AI was assisting the workers to identify the faults. And then augmented intelligence, where AI is performing more general action to assist humans. And we have seen that how AI enabled camera was able to assist workers to identify the fault and referring the fault and checking that image with the database and then verifying that no, yes, it is, this part is all right. So that is augmented intelligence. Then what is autonomous intelligence, which we will be also learning today. What is autonomous intelligence, with some examples of computer vision and visual AI. Computer autonomous intelligence is where AI is operating with much less human intervention, where AI is also guiding the human being and human worker or human being, and also taking action, whatever has been found, and what is appropriate at that time. So that is called autonomous intelligence. So AI is having primarily, if you see, that assisted role, augmented role, and autonomous role. On the right hand side picture, I have tried to capture that in a visual manner, that AI is having three kinds of we can say that the learning, which is being done by sometime by training of the AI models, or by learning them itself by AI algorithms. Around this, what kind of actions AI does, AI enabled devices or AI does, is sensing. It's sensing, and when it is able to sense, we call it sensory AI. Images and videos, facial recognition, speech analytics, these are part of the sensory AI. And there is a cognitive AI. Cognitive AI, where the human-like intelligence is being shown by AI systems, or AI softwares. That is machine learning platforms, which we have learned, that predictive analytics, etc. These are a part of the cognitive AI. And then executive AI. When we ask AI, like Alexa, we ask Alexa, you do this or you play this song. This is a natural language. Here, the executable AI component is more in action. So if you see that, the AI is having three kind of role: sense, think and analyze, and then act. So we will see that in the computer vision technology, all these three roles are in play. Now this is another picture where we are showing that you are seeing here that how AI enabled approach is helping now. If we compare with the traditional approach, where the camera is collecting the pictures, these cameras are collecting the pictures, and no insight, no action, it's just picture, and it can be retrieved and you can see later on. That is sometimes we call it CCTVs. But CCTV is not having any intelligence built in. If we build the intelligence in CCTV, and CCTV is able to figure out that a fugitive or some dangerous element has entered in this building, which they have a record of all these kind of elements and human beings who are tainted people in that locality, then CCTV can. It is possible with the help of AI-enabled approach, which we are going to learn, that computer vision or visual AI kind of systems can provide in high security net. Now, if we like to see as a layman picture of AI, and compare how what is the difference, how the human vision system work and how the computer vision system work. One side, when we see any object, we are able to recognize whether this object is, suppose we are seeing some fruits, whether this is a banana, or whether this is a orange, or whether this is an apple. So after seeing the picture of the fruit, our cognitive capabilities, cognitive technologies capabilities, as well as the visual capabilities, try to diagnose, try to find out whether it is an apple or whether it is a banana. And then in our brain, there is a function which decide that which kind of fruit it is. And then we get a judgment. This is a banana, or this is an apple. Similar kind of function has been simulated to a great extent with the computer vision systems, where a sensing device, when it sees any object, it will have a sense. It will have a sense. It will capture that sense. It capture the picture, and then it will try to diagnose this picture with the help of some algorithm, built-in algorithm, and and that is some sort of algorithm which is, we can say, AI-enabled algorithm or deep learning algorithm, and then it will decide that whether it is a banana, or whether it is a apple, or this is a plate of the all fruits. So if I like to define based on this picture, computer vision is the ability of computers to recognize and extract data information from objects, images, videos, and real life events. Unlike human, computer have a hard time processing visual data. Because we do everything because it is inbuilt in our system, while computer has to process this data. So that's why we call it hard time processing. But it is now with the fast computers, it is not to take much time now. So this is a very handy picture if you like to see the comparison of how computer vision. I'm not saying that computer vision is going to replace the human vision system, because we have some other qualities like intuition, etc., which is not part of the computer vision system. Yes, and this is a picture. I will say simulated picture, which thanks to Google Gemini, that how a smart camera, what kind of functioning smart camera having. I will not say this is a 100% exact picture, but it gives you some good feeling that how the smart camera which you are seeing over here has having one is that onboard logic, the way the edge devices function, and then it also refer backend system for knowing that object, kind of object, and suppose we are using these cameras for finding the anomalies or using for inspection. So naturally, all this data is not residing in this computer vision camera, but it will refer back to the backend system on high-speed network, whatever, and then try to get the information, and accordingly, then it will direct the action what is to be taken. Suppose there is a fire going on, fire has been broken out somewhere, and camera is seeing the fire. Then camera should find out that this is a fire, and then what should be action taken in case of the fire. The camera will direct to the cloud system, will take a decision, and alert will be generated. So this is what I thought a simple picture can show you multiple actions which are emerging out of this smart camera. In this slide I tried to explain you something called visual AI also. Visual AI, computer vision and visual AI are not very different two terms. Only in case of visual AI, we find that there is a much more logic, the way our brain function. Computer vision to some extent is a technology, which is I can say that computer has an eye, while visual AI is a technology where both eye and brain are coupled each other. It has function which is when you say this is a visual AI technology, then it means that it has the power to extracting meaning, reasoning about the content, and make informed decision or trigger downstream processes. So if we compare these two terms, computer vision and visual AI, the one minor difference between, yes, this picture shows that what is the difference here. If you see on the right hand side picture, the computer vision versus visual AI, computer vision is having capability of deduction, while visual AI is having not only deduction, also taking action. It is taking action. So this is the difference between visual AI, and it is the advanced version, or today when we say computer vision or visual AI, it doesn't make much difference. But we have to see the underlying difference, technically underlying difference in the capability of these two kind of technologies. I have given on the left hand side the complete definitions and technical reasons of these two technologies, how they differ. One of the important thing which you can visualize when you read this, these definitions and these technical explanations, you will find that visual AI system evaluate this information within the context of operational data, and then it take decision. Like when there was a fire happened, then it will take decision that in case of fire, it has to have a fire alarm. It has to press the fire alarm, and it has to inform, or it has to generate alert so that all concerned people are being alerted. But in case of computer vision systems, may not happen all these actions. Computer vision system may generate some alert, but not to that extent that it will inform all concerned people. That is what difference between visual AI and computer vision system. So if we like to have a simplified definition of computer vision, this slide is having that narration. Computer vision is a field of artificial intelligence that train computers to interpret and understand the visual world, using digital images from cameras and videos, and currently typically applying the techniques of deep learning. Machine learning can more accurately than ever before identify and classify objects or data within an unstructured format and then react to what they see. Why we are using term here deep learning? Deep learning is as we have learned in our previous lecture, deep learning is very near to the neural networks, how our brain function. So That is what the technology, a part of the technology, or that is the technology is being inbuilt, in the computer vision systems. That's why we say that computer vision systems are both eye and the brain of the computer. They work like eye and brain of the computer. This visual is also showing that computer stepwise function of the computer vision system in a retail store. You can see that there is a computer vision camera which is watching this person who is entering in the store, and a customer scan his QR code, and the cameras track via QR code. Deep learning system track this person, who is this person, and now he is trying to pick up or he is going to select a article, or he is some item from the in the store. Not one item, two item, three item. And computer vision cameras are all the time watching and seeing that what all this person has done, is selecting. And once his selection is over, at the time of walkout, he need not to pick up everything. He will find all these items in the out tray, and the payment will be directed from this payment system. So this is a complete action which is being done automatically. And here the manual intervention is minimum. But you see that technology is always in the play. Always cameras are watching this person in action, and then debit or credit card is being charged for the goods which he has purchased. A very latest example, Meta and Raymond has joined hand, and they have launched a very new type of spectacles which are having I will say magical kind of functionalities. Like I am wearing my spectacle, it is only providing me the eye vision. It correct my eye vision. But this kind of spectacles, intelligent spectacles which Meta and Raymond has come out, is having multiple other facilities. It has one side the augmented reality, virtual reality kind of functionality. It can also direct that what you want. You can communicate the way you communicate to the Alexa that you want this picture to be seen. You want this function. Like you see in this picture. In this picture, this person wants to ask, how old is this building? Then he get this person is being identified by WhatsApp, and then he get a message that this is a Qutub Minar and it is built in 1192 CE, and it is a 250 feet high. So that is the way this technology is empowering human being now, and this is a recent launch. I have also put a slide, the key functionality of Meta Ray-Ban AI glasses. This is being called Meta Ray-Ban AI glasses, and it has this kind of overlay and elements, HUD panels, then boundary box around the building of objects, which with level of, because this is a boundary box, give that information to the ear of the person. A live in translation panel, this is also very important to understand. Even you are speaking some other language, it will translate that. The computer understands the language. This Meta Ray-Ban AI glass is, if I like to give a layman kind of functionality, in layman language I like to describe this functionality. It has one side that capabilities of like Alexa, other side it has capabilities like computer vision camera, and third side it has visibility of seeing the visibility like augmented reality, where it was giving the any object information in the augmented reality in the context. So that's why it is called on device, computer vision, AR and display. What kind of technologies are being played? This slide give us that explanation. This camera has been built. This kind of Meta glasses has been built with the help of or the conversion of these kind of technologies. One side computer vision, camera, AI language model. So as we started this second week, with the theme of the convergence, you will see a very great example of convergence in this kind of gadgets, which start coming in the market now. I am trying to explain some of the other use cases or use of computer vision quickly. Computer vision is having wide use cases in the manufacturing, like barcode recognition, intelligent character recognition, OCR character recognitions, and optical mark recognitions. Then a very good example, live example of computer vision. The high-rise towers has developed some fault. this is the electric tower has developed some fault. It is very difficult for a person to climb, and that's through the electricity is running in the tower. No. So here, no, we normally nowadays, technician or companies make use of the drones, which are attached with the computer vision camera, and the computer vision camera is directed to the area where there is a likely fault, and it take the picture, it try to understand what is the fault, and it communicate to the ground. It communicate this picture as well as the what is the reasons to the ground technicians, and they can take a decision that what kind of fault is this, and what kind of remedy or what kind of action they should take it. This is another example of computer vision with security intelligence, we call it, and it is being widely used in security intelligence gates. So I have put 4 or 5 other examples also. You can go through these examples where the computer vision use is being done in the maintenance. Very great use of the computer vision in the package inspection. Nowadays is very common and not very expensive. Where you can see a camera is watching that packets and trying to figure out that in this packet what kind of medicines are there, whether it is a complete thing, is there any shortage in the medicine packaging, and if it is found some shortage, it will immediately alert, or it will immediately figure out that this packet can be taken out. This is another very great example of computer vision in the product assembly. It helps the workers in doing the product assembly in any of the kind of manufacturing plant, so that if any anomaly is there, the workers can find out this anomaly and take them remedial actions. This is a different use of the computer vision in the case of safety on the field, personal safety in the field, where computer vision camera can figure out that where is the staff, and whether they are wearing all safety gadgets correctly or not. If they are not wearing the safety gadgets, then the alarm is generated to the control room that so and so staff has entered in this area, and they are not wearing the required safety glasses or safety helmets, etc. This is another example of defect detection, where computer vision, as we have seen in case of BMW, computer vision technologies or AI technologies are being deployed to identify the defects in the parts or in the machine. And the video I have attached here can be, you can see this in action, how this is being done. Just play this video and try to get little more information about this. There are many use cases. As we said before we come on the smart manufacturing or some other concept, we thought it is better to discuss these technologies. In this slide I have given name some of the use cases which are being commonly used in some those industries which has been certified by the World Economic Forum, WEF, as a lighthouses, global lighthouses. So I have taken these examples from the stories which has been published by World Economic Forum about the lighthouses. Now, to summarize that computer vision framework use cases in a single slide, this is very useful slide, which PwC has published, that various kind of applications are being used around the computer vision and AI, visual AI technologies. One side, it is helping the document intelligence. Other side, product intelligence, equipment intelligence, people intelligence. So you can see that in case of the equipment intelligence, self-driving vehicles. In case of so its use of virtual AI and computer vision is multifaceted. And I will invite you to go through this slide little step by step, and you yourself will figure out that the use of these technologies in all these kind of industries and use cases. Now I am coming to the last part of this session, where I like to share with you the detailed study by a scientist David Marr. He has published one book, which the reference of that is given over here in the next slide. And he mentioned about this technology which can be understood by 3 layers: computational layer, algorithm layers, and implementation layer. And you will see the explanation of this computational layer and algorithm layers, or the functioning of the algorithm layer and the implementation layer in this slide. So if we quickly see that what is the function of the computational layer, it defines what the system does and why the underlying. So what is the goal of the computation? Why it is being appropriate? When you want to build any computer vision logic or computer vision system, you should first work out at the computational level. What kind of computation in this system or this device should do that? Then what for doing that computation and to achieve that goal, what kind of algorithm we require For algorithm we require, and to implement the algorithm, what kind of hardware is required. So basically, whole this life cycle of this computer vision camera, which we call it software and hardware, work in the three layers. Computational layer, algorithm layer, and hardware layer. More details you can see by looking into this video, which is around I think 10 or 12 minutes video at the YouTube. And this picture, I have shown you that three layers in action. The first layer is detecting the basic scene and image element, and that is done by the computational layer, and then detecting and tracking the object and regions, that is being done at the algorithm layers, and the detecting activities, it is being done at the implementation layer. So this is a textual explanation of what I have explained so far about these three layers. And now we have come to the end of this session, and I'd like to summarize that in this week we have learned following things. One, we have learned in the first session that the associated technologies, especially the AI and associated technologies, and we have also learned their collaboration and convergence, role of AI and associated technologies, in the first session. Then in second session, we have learned the very important technology of AI. It's called the robotic process automation and intelligence, RPA. How it is helping the industry, how it is automating the processes of business processes and enterprise processes. Then in the third session, we have learned 3D and additive manufacturing, which has a wide use in the manufacturing, and how it is helping the manufacturing industry and some other industries as well as. And in the fourth session, in the last session, we have learned that what is the augmented technologies like AR, VR, and mixed reality, and their architecture as well as their use. And today, in this session of the fifth session of this second week, we have learned the use of computer vision and visual AI. With this, we have come to the end of the second week sessions. Thank you very much.